Now that we've gotten all the basic information that we need, we've learned about light, we've learned about telescopes, and we've gotten a historical perspective of how scientists realized what our solar system looked like. Now that we've done all that, we're ready to move on to our next section, our next unit, which is our solar system. And the first thing that we want to know about our solar system is basically, how do we think it formed? So, when we're studying the solar system, we want to think about, first of all, we're going to approach this from a scientific approach, which means that we're going to gather all our observations that we can make about our solar system, and then we will try to think of a way that this could have come about, what kind of formation process could have happened that would actually result in the solar system that has these characteristics. So the first thing we'll have to do is think about what it looks like. We want to sort of think about all the different planets. Can we compare them to each other? How are they similar? How are they different? And then when we have all this information, we, in terms of what the solar system looks like and our different types of planets, then we'll have to think about some sort of scenario that seems scientifically valid and likely as to how the solar system may have formed. So first, let's just look at this picture of the planets that we are familiar with in our solar system. I know Pluto's included in this picture, but as we'll learn through our studies, Pluto has been demoted. It's considered a dwarf planet, but it's still something that we'll still talk about. So the first thing that we might notice when we look at this picture is how much larger the sun is than all the other planets. The sun is huge, and this picture sort of puts it in perspective. The next thing that we might notice is that these four planets here, Mercury through Mars, we know are the planets that are closest to the sun, and notice that those also are much smaller than the next group of planets, Jupiter through Neptune. And so that starts off our whole process where we see that there seems to be planets that have things in common with each other, but then there are planets that are different from each other. And so what we find is the four planets closest to the sun have a lot of characteristics in common in terms of their size, their makeup, the conditions on those planets. And then the next four planets, Jupiter through Neptune, those planets sort of go together and have some similarities in terms of their size, their makeup. One of the things that we might not be obvious to us in this picture is all four of these planets actually have a ring around them. We can see a really faint ring around Uranus, but we don't see the ring for Neptune, but Neptune does have some rings as well. That's something we might not have actually realized. We all know that Saturn has those pretty rings around it, but we might not have realized that these other planets, Jupiter, Uranus, and Neptune, also have rings around them. So, what we're seeing here is our planets are divided into two groups. The four planets closest to the sun we call the terrestrial planets. Characteristics of the terrestrial planets are that they are relatively small. They're actually made up of dense materials because they're made up of heavy metals and rocks. They have very thin atmospheres. They have relatively weak pulls of gravity because of their small size. Their temperatures on these planets are relatively high, and the term relatively is pretty important here because if you were on Mars, you would be very cold, but compared to the temperature on Jupiter, Mars is quite warm. And and of course then it's also going to take them a shorter time to orbit the sun. The separation between Mercury and Mars is actually relatively small. Mars is about 1.5 astronomical units away from the sun. And then there's a relatively large gap between Mars and Jupiter because Jupiter is about 5 astronomical units away from the sun. And then when we get out to Neptune, we're talking more about, excuse me, about 35 or 39 astronomical units. So these planets are all spread out a lot. Okay, so we have the four planets closest to the sun. We call these the terrestrial planets. The next four planets we call the Jovian planets. And the Jovian planets have characteristics in common as well. They're very large. They have low densities, actually, because they're primarily made of hydrogen and hydrogen compounds. They all have rings around them. They have lots of moons orbiting them. They have very thick atmospheres. They have relatively strong magnetic fields. And I think that's, in terms of the things I can think of off the top of my head, those are the main characteristics of the Jovian planets. Then there's Pluto. And you can see when we're classifying the planets into the two groups, you can start to see how Pluto doesn't really fit in. It's not big like the Jovian planets, but it is made up of ices. It's not really a rocky terrestrial planet. So that's the first thing that we observe about our solar system, is that the planets that are found in our solar system tend to be grouped into two different categories. The other thing that we have to think about is how things move in the solar system, and what does the solar system look like. So again, keeping in mind that when we're answering these questions, we already looked at the planets and talked about the different things we know about them. And now we're going to take a look at the solar system, sort of its appearance and the motion in it. Keep in mind that what we're doing is we're gathering observations that we know our theory has to match in order for it to be a valid scientific theory. That's the way we have to approach things a lot of times in astronomy, because we can't simply sit around and wait for a solar system to be formed. All right, so here we're going to just summarize what we said about the planets. This might help you to see this in print. The two classifications or categories of planets. Like I said, the terrestrial planets are the four planets closest to the sun. That would be Mercury, Venus, Earth, and Mars. They're much smaller in size and have small masses, but high densities because of the fact that they're made up mostly of rock and metals. They have solid surfaces. They don't really have a lot of moons. Actually, Mercury and Venus don't have any moons. We only have one moon, and Mars has two very small ones. They are closer to the sun, closer together, and are warmer. Then when we get to the Jovian planets, like we saw, they were much larger, and of course they have a much larger mass, but they have a lower density due to the fact that they're made up of mostly hydrogen, helium, and hydrogen compounds. Another interesting fact about the Jovian planets is because of what they're made of, they don't actually have a solid surface. You couldn't actually go stand on the surface of Jupiter or Saturn. We saw that they all have rings, and I also mentioned that they have lots of moons. They're also farther from the sun, they're spaced further apart, and they actually have very low temperatures. Now let's look at the appearance of our solar system. First of all, let's talk about motion. Now in this picture, what they've done is, because of the fact that the terrestrial planets are much closer to the sun than the Jovian planets, they sort of blew up the orbits of the terrestrial planets here for us. And what we should notice is the things that they're trying to show us are the direction of the orbit. So remember, that would be the revolution, the direction of the rotation of the planets, as well as the motion of the satellites that orbit around the planets. This is the view we would see if we were looking down from the top of our solar system. And what you should start to see is there's this overwhelming motion in the counterclockwise direction. Planets are orbiting the sun counterclockwise. The sun is rotating counterclockwise. Nearly all of the planets orbit counterclockwise. Two exceptions are, well, we have actually three exceptions. We have Venus is going clockwise. although it's rotating very, very slowly. Uranus is going clockwise. Uranus is actually almost lying on its side, and it's just barely going counterclockwise viewed from the top, and Pluto as well. So there are some exceptions to that motion. But overwhelmingly, a counterclockwise direction for revolution of the planets, rotation of the planets, and also the revolution of the planet's satellites around them. So we want to keep that in mind. This is looking at it from a different view, and what you might notice is that also the orbits of the planets seems to be relatively confined to a disk, more or less. The only one that deviates a decent amount from the disk shape of the solar system is Pluto, once again. So almost all the planets are lying in the same plane, which is also important. There are these other objects in our solar system we also should be aware of. These are the asteroids and comets. Asteroids are primarily found between the orbit of Mars and Jupiter, while the comets are found out beyond the orbit of Neptune, and actually can also surround our solar system in a more spherical manner, because some of them come down from above, as we're showing right here, and also could come up from below. There are these other dwarf planets. Here is Pluto and its moons, and we'll learn later about some other dwarf planets that have been found in our solar system. So basically we want to try to sort of sum everything up, because the characteristics that we've been observing about our solar system are going to be the characteristics that need to be explained by our theory of how our solar system was formed. We really sort of summarize this into four major characteristics, and they are that the large bodies in the solar system have orderly motion. So that was basically the idea that they're all moving in the same direction, that counterclockwise direction, as well as the rotation of the planets and the revolution of them and their satellites. We have planets fall into two main categories, which are the terrestrial and the Jovian planets. We do have these asteroids and comets. We have to be able to explain those. And then there are some exceptions to our general rules, such as that some of the planets have odd tilts. I had mentioned Uranus is almost lying on its side. Here is sort of what we would think of its north pole is below horizontal to its orbit. And Venus, of course, rotates backwards as well. The moon is actually considered a little unusual, our moon, because it's very large in comparison to the size of the planet. And some of the moons found in the solar system do orbit in a clockwise direction around their planets. So we do want to be able to explain those as well. So these are the major characteristics that we need to have any theory of formation of our solar system explain. And we'll continue with those and look at how we think our solar system formed in the next slideshow.